All right, guys, we've had a couple of technical difficulties, but hopefully we will be back on track here. I got my mouse, so we should be hopefully a little bit better there. Okay, so after you have tallied everything, you are going to see that you have 2/4 inches, and then you have 3 of everything else. And you would put those in the tally chart, and then you're going to convert those over and just make each tally an X on the line plot over on the right here. And there are equal amounts of all sizes except for the 1/4 inch because there's only 2/4 inches and there's 3 of everything else. Does that make sense? Okay, so this one says, what do the X's represent on the line plot in example 2? So if you haven't done this one, you pause the video now and just see how you would answer that question. We'll move on, and you need to know that each X represents the number of paper clips that are a fraction of an inch in length. So each X is 1 paper clip that's 1/4, 1 paper clip that's 1/4, 1 paper clip that's 1/2. So write each X represents a paper clip of that fraction size. Okay? All right, we are going to move on to independent practice. However, because you don't have 8 people around to measure their pencils, I'm giving you pencil lengths on the side, pretending that we did that in class. Now, if we read the directions, it says, measure 8 friends' pencils to the nearest inch. So, no fractions in this one. These are all just full inches. And I want you to use the information that I've put on the chart right here, fill out your tally chart, and then answer the questions. So go ahead and pause the video and answer those questions, and then we'll start up again. Okay, so we have to put these on a tally chart. Let's see how we did. 4, oh goodness. We have 4, 5, 6, 7, 8, 9. And I don't have a lot of room down here, but 4, 5, 6, 7, 8, and 9. Okay, so remember with the line plot, when you're taking from the tally chart over to the line plot, you're going to put an X above each one. Look at that. X is looking better with this mouse, isn't it? And 1/5, and 2/6, and 2/7. That kind of looks like a Y. And 1/8, and 1/9. Okay. So now the question is, what is the difference in length between the longest pencil of 9 and the shortest pencil of 4? So what is that difference? So sometimes it's hard to see what kind of a problem that is. But if you're looking at your ruler and you'd be like, okay, the longest one goes here to 9, right? And the shortest one goes here to 4. What is this space in between 9 and 4? How many is that? Well, you could count and you could say 1, 2, 3, 4, 5. Okay, that's 5 inches of difference between the two. You could also probably do a subtraction problem, which is I think what they're asking you to do, because they said write an equation with the letter P for the unknown. We know how to do this, right? So we would say 9 minus 4 equals P. And then we're going to say P equals 5. Why am I doing that? Because it says then solve. So you need to say P equals 5, right? Or 5 inches. I should say inches. Okay, what would be the total length of the pencils if they were laid end to end? So if you took all the pencils and laid them side by side from end to end, how many would that be? Well, we're going to say that would be 4 plus 1 5 plus 2 6s. Maybe we could just add that in our head because 6 plus 6 is 12. Could we do that? Would that be okay? And then 2 7s is how much? That's right, 14. Plus, I know 8 plus 9 is 17 because 8 plus 10 would be 18. That's easy. And then 9 is 1 less than that, so it's 17. So I'm just going to put those two together as well. Now, 4 plus 5 I know is 9. So I'm just going to come over here and say 9 plus 12 plus 14 plus 17. Now, if you find a bit more effective way to do this, that's fine. I'm just saying this is how I would probably work it out. So 7 plus 2 is 9, right? So I'm going to be like 7 plus 2 is 9, and 9 plus 9 is 18, and 18 plus 4 is 22, right? Because 18 plus 2 would be 20, and then you have 2 more, so it's going to be 22. So I'm going to put the 1s right here, and I have 20, which is 2 10s. And 2 10s plus 1, 3 more, that's going to be 5 10s, so that'll be 50. plus the 2 is going to be 52. That makes sense? 52 inches. Okay. All right, now we need to go to the next one. This one gets a little bit trickier. It says, use the same pencils. But in the first one, it said round to the nearest inch. So if you were at like 6 3/4, you would have just rounded up to 7. If you were at 5 1/4, you would have just said, oh, it's closest to 5, right? To the nearest inch close to where you were marking it. So maybe we should do an example of that. So, since we didn't actually measure those pencils, for example, I have to put the end of the pencil. So let's look at this. I hope you guys can see this, but on this particular ruler, I don't actually move the pencil all the way to the end because the 0 starts right here. And remember some of our rulers at school said start here, and it showed us where to put the end of whatever it is we're measuring. So if I take this pencil and I go to the end, it's almost a 6. It's really closer to 5 3/4, but it's almost a 6. So if I was rounding that to the nearest inch, I'd say, well, that's just about 6. It's a lot closer to 6 than it is to 5, correct? Can you guys see that? I'll hold that up there. Can you see how that's much closer to 6 than it is to 5? So we have to say that would have been to the nearest inch. Well, this one says use the same pencils, measure them again, but this time to the nearest half of an inch. Okay, so I think I wrote those down. All right, so we had one that was 4. We're going to say the one that was at 4 still was actually, it really was exactly 4 inches. Well, that could happen, right? And there was one that was, it was really closer to 5 1/2. It wasn't that close too. So we had one that was 4, one that was 5 1/2, but it was like a little less than 5 1/2, so we rounded it to 5, but it was really pretty much 5 1/2 to the nearest half an inch. So if we had a pencil that was like this, and it's almost to 5 1/2, you're going to say that's 5 1/2 because that's the nearest half an inch. It's closer to 5 1/2 than it is to 5. It would be closer there if it was closer to 5. So it's a little bit like rounding. You have to say, is it closer to 5 1/2 or is it closer to 5? And for that one, we'll say that one was 5 1/2. And then we can say we had still 2 that were at 6. And then we'll say one was at 7 1/2. We just had one tally there. One was at 8 1/2. Actually, we'll give those 2. We'll just say both of those are closer to 8 1/2. And then 9, we had 1. Now, it might be a little bit different if you were actually measuring these pencils, but in order for us to cooperate together, we kind of need to have the same set of data. So I want you to put this data in the line plot again. So go ahead and pause the video and then answer that question below as well. Okay, so when I'm doing a line plot, you still have to make it look like a line, right? I'm not going to say, okay, here's 4, here's 5 1/2, because that's just the next thing that I have. Here's 6, here's 7 1/2, right? It doesn't work like that. When you're putting it on the line plot, you still have to have it spaced exactly like you would a number line. So I'm going to say, here we go. Oh, that's a little thick. Where is that? I'm going to say here, oh goodness. Okay, we have 4, 5, 6, 7, 8. I'm going to make that a little bit longer. You can make it longer. 9. Okay, and then we're going to do half inches in the middle. So it's a little bit more detailed of a line plot because it has half inches. So this would be 4 1/2, 5 1/2, 6 1/2. If you did not space them out correctly, redo it so that you have it on there right, because you really do have to make it look like a number line. There has to be even spacing in there. Okay, so we're going to put an X over 4 and 1 over 5 1/2, 2 over 6, 1 over 7 1/2, 2 over 8 1/2, and 1 over 9. Okay, how are the two sets of data different and how are they alike? So if I was going to just move forward to that, we have information so that some way that they're different is we're still measuring, or that they're alike is that we're still measuring the same pencils. We are still having the same number of pencils measured. We still have 8 pencils measured. Like that those are some ways that they are the same. How are they different? Well, it would be great to see what some of your examples are. We actually, in the way that we did it, we kept the same spread, but maybe a pencil that you had measured 5 inches, maybe that would have been closer to 4.5. Maybe those would have changed. You would have had more numbers in different categories. For ours, we still had 1, 2, 1, 2, 1, 1. But perhaps in other ways, you could have changed categories of fractions. It could have moved, and maybe I wouldn't have any in 4 anymore, and I would have 2 and 5.5. Right? So we could say they're different because we added half fractions and moved some of the numbers around, right? We got rid of some of the 5 numbers and put numbers in different sections. So that's what we're going to put for how they are different and alike. And if you have different examples, I'd love to see what you guys did. You can email me or let me know. Okay, problem solving. This page, they are giving you all of the information. So I really want you to go through and answer all of these questions. After you're done, we're going to go over it really fast so that you can check your own work. And normally, I would just check this work and kind of fix as we go, but we are actually going to check it together to make sure that we have a solid understanding for this year. And that's probably how our lessons are pretty much going to go from now on. So pause the video, answer the questions, and we'll come back. Okay, just to save time, and because even my mouse handwriting is not as good as what the computer has, we're going to look at what the answers are. So it looks like they took from the frequency chart for a 1/4 inch, they put an X here. For the 2/4 of an inch, or what does that equal? Half. They put 4 of them because they have 4 numbers. So remember, when they say several students measured small items from home, and this is the frequency table is different than a tally chart because it gives you the number, whereas a tally chart gives you the tallies. 3/4, we have 5 X's. 4/4 equals how much? 1 whole. That's like a whole inch. We had 2. 1 1/4, we had 2, and 1 2/4, which is also equivalent to what? 1.5. We have 3. Okay, what is the total number of items that measured 1 inch or less? So this is an inch, right? This 4/4 is an inch because that equals 1. So this and all of these that are less than that, let's just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh! Well, we can say you are correct, book, because we just checked you. Good. Okay, if we go down to number 9, write an equation that shows the difference between the total items that measured 1 inch or less and the total items that measured more than 1 inch. Ooh, that's interesting. Okay, so we decided that 1 inch or less was 12. Well, what about more than 1 inch? How many of those do we have that are from here? From this section, all of these this way. How many are those? Let's see, 1, 2, 3, 4, 5. So there are 5 that are more than an inch, and there are 12 that are an inch or less. So if we are going to be showing the difference between those two, what do? Right, you subtract. So if I was going to subtract it, I would say 12 minus 5 equals T, or you could say P or Q, right? You can use whatever you want for this unknown. And then 12 minus 5 is 7. And so it's 7 items difference between the 1 inch and below and the more than 1 inch. And I would even, if I was going to do this totally correctly, I would say T equals 7 items, right? That's the most correct way that we could write that. Okay. How is a ruler like a number line on the line plot in exercise 7? Well, let's go back to 7, my friends. Okay, how is a ruler similar to this number line? Go ahead and pause the video and try and answer that question. Okay, let's look. An example that they give is the line plot number line is divided like a ruler when you are measuring. The same markings are there as are on a ruler, which is correct. A number line Sometimes you're going to just get this section of a number line. You're only going to have it from like 5 to 9. But if it has fractional markings in there, especially if you're measuring in inches, you'll have halves and quarters, and you can measure it just like you have a ruler. That's an interesting way to think about it. Okay, why does recording measurement data lend itself to a line plot display? I'll go ahead and pause that. Try and answer it. Okay, a line plot uses a number line and it can be divided into the number of parts as needed. I feel like that's kind of a complicated answer. I think that recording measurement data is a way to explain that would be to say, if you're recording measurements and you're using quarters and fractions, a line plot is great because it can show you those quarters and fractions similar to a ruler like they talked about in the previous question. So those are what I would answer for the hot problems. And if you have a different answer, email it to me. I'm curious to know. It's interesting. I miss your guys' answers and your faces and your ideas. All right. If you want to go on and do your homework pages, you are welcome to. I am going to let you pause the video and then I will have the answers show up and then you can pause the answers as well so that you can check your answers. It's not required, but I think it would be a good idea since we're not there to go over things more in depth. So go ahead and pause it. And if you want to pause it here and look at those answers and see if those were the ones that you got, that would be great. You can pause this here if you want. Here are the answers for your homework if you want to check that out. You can pause it on the screen too and double check, make sure you got them right. And then we can try this one as well. Go ahead and pause it. And then you can pause it again to check your answer. Pause it. There you go. You can also pause it and do all the problems and then come back and check your answers as you go. So you could just pause it on each piece. Okay. All right. If we need to go over your homework answers, if there's things that are still confusing, I would love to get your feedback. Hey, Mrs. Philpott, this problem was really confusing to me. I still don't really understand this part of it. That's sort of the beauty of doing this online school is that we can do an extra lesson on anything that you still find confusing. So please email me your feedback. All of your papers will be due. You just need to take a picture of it at the end of the week. So all of our lessons this week from Tuesday through Friday, there should be 4 of them. You'll just have to have your parents take a picture of, they don't have to take a picture of the homework pages, just the 2 pages that we did. So pages 731 and 732. Those are the 2 pages that they need to take a picture of and turn in to me so I can give you credit for that. And here we have our answer right here. And again, email me if you have questions. We'll see how this first week went, okay? All right, see you soon.